Welcome to higher derivatives. Okay, so do just a simple exercise. Find the first four derivatives of each function. So function 1, if function 1 is y equals x to the fifth power plus 3x to the second power, we know that the first derivative, dy dx, also can be annotated as y prime is equal to 5x to the 4 plus 6x. Now, simply the second derivative and the third derivative and the fourth derivative is just the derivative of the previous one. So you can see if the derivative is equal to, the y prime is equal to 5x to the fourth power plus 6x, the second derivative is just the derivative of that. So that's where we get the 20x to the third power plus 6 for the second derivative. The third derivative is 60x to the second power, and the fourth derivative is 120x. So again, here's another example. The first derivative is going to be 25x to the fourth plus 6x to the second minus 8. Take the derivative of that as the second derivative. We've got 100x to the third plus 12x. The third derivative is 300x squared plus 12. And the fourth derivative is 600x. And here's an example of higher derivatives applied. We know that velocity is equal to the derivative of distance. And acceleration is going to be the derivative of that, of velocity. And another way to write this is acceleration is equal to the derivative of velocity and the second derivative of distance. So here's that applied. If we've got s is equal to negative 4.9 meters times t to the second power plus 500 meters, we can simply take the derivative of s, and we find that v, the velocity, is equal to negative 9.8 t meters per second. And you can see the unit there, because it's ds dt, s is in meters and the dt is in seconds. Now to find acceleration, we've got the derivative of the velocity, which is also equal to the second derivative of distance. So the second derivative of the distance also kind of shows us really nicely what the units are in. So we know that the derivative of velocity gives us the negative 9.8, the t falls off. And then the units, we can see that s is in meters, and that the t now is squared. So we've got negative 9.8 meters per second squared is our acceleration.